What's going on, folks? I've got my regular introduction. We've got Adriana here. Oops, I guess she doesn't want to be seen. And then we also have Mitchell over there in the off scenes over there. I'm sorry, did you not want to be in the picture?
I already am.
It doesn't matter anymore. Alright. Hey, how's it going? Can you hear my voice? Can you see my face and all of that kind of jazz? We covered that already. Let's talk about the homework and whatnot. How you doing? Are you guys doing alright?
No.
Why not? School is
I'm
hard.
here, that's why.
Oh, Mitchell's here. He seems to be pretty happy. Although, he's turning in less homework than you are, so I mean, he needs help too. So, don't feel bad. Alright, anyway, I graded your homework for page 15 and 16 for chapter 2 stuff. The stuff you turned in like yesterday and the day before that. And a few of you got it. There was a good number of you who actually didn't get it. So I realized that maybe I probably should have covered that a little bit better. In fact, that's kind of what we're talking about today. So don't freak out if you didn't do well on the homework. People who actually normally do well actually didn't do well on some of them too. So what I would like for you to do is redo the assignment. I'm gonna go over and remind you guys how to do it. I'm gonna ask you, does everyone understand? And if you guys understand, indeed, then redo the assignment. Cool? By the way, here's a pen, and you want to pull out your chapter 2 stuff. We're going over quad 2 real quickly to make sure that we remember how to do some of this stuff. So I talked about. All right, so I've got my review hat on, and then later on I'm going to have my cover new material hat on. So we talked about how we talked about parabolas, right? And we talked about like how many times I asked you how many times does this thing cross the x-axis. Why would I care about how many times it crosses the x-axis? Right, exactly. Because the point of doing a parabola is the old school point was when we threw things, right? We want to know where it lands and where it starts. Like those are the two most important parts, or where it hits the ground, right? And so that's kind of what we call the solution to the parabola. So if you look at this graph right here, can you see that? Can you see? I'm on page, I have no idea. I'm on page like 14, I think. Let me look. Or 13. Oh, I'm on page 13. Well, no, I'm just going back a little bit to remind you guys what's going on. And then I'll cover page 14 and 15, or 15 and 16 in greater detail and show you guys how to do it. But once you guys understand this, it should be cake. All right, check this out. Ready? So look at the parabola that I have on graph on page 13. Where does this thing cross the x-axis? Where does it land? What are the solutions to this? Awesome. So -1 and +1. I know, it's hard to see. Hold on 1 second. No, the computer's not responding just yet. It's going to take a little bit. Once it figures out that I'm using Paint, then it actually does well. But for now, it's like, wait, I don't know what it's doing. And then it's going to say, okay, fine, I got it. There we go. -1 and +1. We cool? Like, we're looking at that and it's like, on the x-axis, it crosses a -1 and +1. And that's it. That's it. That seriously is page 15 and 16. That's all you do. All I'm asking is, where does this thing cross the x-axis? That's it. I'm done. I mean, I'm not. I mean, I can show you what I mean by -1 and +1 being a solution. It's not really -1 and +1. What it is it's if I wanted to tell you the exact points, this point would be -1, 0. Right? And then this point would be +1, 0. Those are the two solutions, technically. And then the first number identifies the x1, and then the second number identifies the y value. Right? You guys know this? Graphing coordinates and that kind of stuff. So what I mean by -1 and +1 being a solution is if I plug in -1 into here, x squared minus 1, is that going to end up being a true statement? So if I say, okay, fine, what is -1 squared? -1 squared is not -1. It's +1 because -1 times -1 is positive, and it's 1. It's details that make a big difference, buddy. All right. -1 squared is +1 minus 1. So remember, because I have +1 over here, minus 1. 1 minus 1 is, runs with a 0. Starts with a Z. 0. There we go.
Are you quoting Hercules?
Really? I don't know. I wasn't actually quoting Hercules. Oh, here is 0? Yeah, all right. 0 to hero, just like that. All right. Well, I have kids, and so I watch a lot of kids movies. No, but you're kind of a kid still. I mean, is that offensive? I guess compared to me, I just feel like you guys are so much younger than I am. I think you are. Like, I have friends who have kids your age. So, maybe, yeah, never mind. I'm sorry. I'm sorry. I didn't mean to be offensive. You're quite a young adult, and enjoying cartoon movies when you're a young adult is totally fine. I enjoy cartoon movies. I just watched Cloudy with a Chance of Meatball like 2 days ago. All right. The second one wasn't as good as the first one.
I like the second one.
Really, the second one just wasn't as good. The first one was amazing. It was like mind blowing. I had all my physics friends watch it, and they're grad students at UH. If I plugged in +1 into this thing, would this end up being a true statement? If I plug in +1 into x squared, what would it end up being equal to 0 at the end? So what's 1 squared? 1. And then subtract 1 from that.
0.
0. We're good. We're good. Do you see how this is a solution to this problem? We cool? All right. See, if I go over this thing with you, it kind of will. You'll kind of say, "Oh, okay, this whole thing makes sense to me." All right. For what values of x squared minus 1 is it bigger than 0? Well, my answer to that is, when are these y values going to be bigger than 0? And it looks to me like it's these x values over here. Does that make sense? So I would say when x is smaller than -1 or x is bigger than +1. And no, Diamond, I would disagree with you because what you're saying is Tommy's like, okay, fine, disagree with that. No, what you're saying is you're saying this region right here. That's what Diamond is saying. She thinks it's over here. No, I would say actually just the opposite of that. You're talking about not in the middle, but outside of that. So we got to cover 2 areas. We got to cover when x is smaller than -1 and when x is bigger than +1. Do you guys understand what I'm going at here? Yes, you do? I know you guys are thinking like, oh my gosh, this is like such a slow review. Like, oh, why is he reviewing this? Is that how you're feeling? Okay, all right. I don't know if I'm getting that vibe where it's like, oh, yeah, duh. Yeah, everyone knows that. No, but I mean, but what I'm saying is like, all right, fine. And if anyone knows that, then all of you guys should have done it correctly. So apparently, not everyone knows this. What's going on, Brandy?
I have packet 2 most of it done.
Good, because you didn't turn any of it in. All right. When is this one? When is this graph less than 0? See how when is the range going to be less than 0? Can you move in?
Yeah.
All right. And then you'll probably need to set up a computer over there, Brandy. Log into WebEx. When is this thing less than 0? And what I'm asking is, when does this parabola dip below the 0 line? And that's where I would agree with Diamond's statement where I say, okay, it's -1 x 1. Where it's between -1 and 1. We cool? So like this one is saying the outside. And then this is saying between or inside. And yes, by the way, Paige asked, who's that? And Raimana said, that's Adriana. So I've got Adriana hanging out. All right, do you guys understand this? You sure? You got this? This is kind of elementary, but you got it? We covered this like 2 weeks ago. All right. then in essence, this homework set should be pretty straightforward. Like, all right, let's do one of them. Fine. X squared minus 9. Here's the graph. X squared minus 9. It looks like that. Where does this thing, we're on page 15 now. We're doing problem number 1 together. Where does this thing cross the x-axis? That's all I'm asking. Where x equals negative 3 and positive 3. So I'll just put plus and minus 3.
That's it?
That's it. Yep. Yeah, that is it. I'm not kidding. That's it. That's it. That's it.
Okay.
Okay, well, what about number 3? Let's try number 3. Okay, wait. Here, I got an idea. Because this kind of touches on what we covered last Wednesday, which was a little bit of chapter 3 stuff. But let's do that. Say that we don't want to graph it. Say that we want to actually solve it with math and not graph it. All we do is this. X squared minus 9 equals 0. How do I get the x squared all by itself? Plus 9. All right, cool. So it's x squared equals positive 9. We cool? Now, how do I get rid of the square part? I square root it. But there's that funky thing that happens when I square root something. I have to toss in a, you guys remember? I have to toss in a positive and a negative. I have to toss in that plus minus thing. What is the square root of 9? So it's plus minus 3. And you can actually see why I have the plus and minus in it. It's like, boom, that's up. All right, you can actually see why I had the plus and minus there, because in a parabola, it crosses twice. So you have to consider that plus and minus. We cool? Yeah? Good? You guys all like this? So, in order to solve this problem, you didn't even need to do... First, you didn't need the graph. You could have just solved it algebraically. But that's a little bit advanced. All I'm asking you to do is look at the graph and where does it cross the x-axis? And you can actually just kind of like, let's do number 3 together. Where does it cross the x-axis? Plus minus 2. That's it. We cool? Are you logging?
Yeah.
Okay, yeah, it was causing feedback because there was a loop, but we good? All right. So, do you guys think you guys can do this homework? All right, let's talk about this one real quick. 16 is... There we go. Let me see.
Yeah, what if it doesn't?
All right, that would be a good question. I'm just going to ask that in general. What if it doesn't cross the x-axis? What if it like misses the x-axis? What is the solution there? Exactly, undefined. That's what she's saying. Or, I don't think it's more so undefined as it is, there's just no solution. The thing doesn't cross there, so there's no solution in there at all. So you just wrote no solution. I mean, what do you want me to do? You're asking me when this thing crosses the x-axis, and the damn thing doesn't touch the x-axis, so how am I going to answer your question? Right? That's what you would tell me. Right? Now, for all of the times that we've been asked, all of the problems we've been looking at, there's been 2 solutions. Plus, minus, whatever. Plus, minus 2. Plus, minus 1. Plus, minus 3, or whatever. Right? Could there be a case where it doesn't touch twice, but it doesn't touch no times, it only touches once? Yeah. And in that case, what would you tell me? What would the answer be? You would only give me how many numbers? You would give me one number. That's it. Are we cool? Awesome. Now this one's a little bit funky.
I realize that this one could be hard to solve, but some of you folks figured it out. In essence, what I'm doing is this. I'm asking you, when is x squared plus 1 smaller than 5? Okay? Look at number 11 on page 16. When is x squared plus 1 smaller than 5? Or what you could do is this.
Can I?
Get that 5 onto the other side.
So
Would it be, I just subtract 5 from both sides, right? So I have x squared plus, well, what's 1 minus 5? X squared minus 4 is smaller than 0. That's all I'm saying, right? When is x squared minus 4 smaller than 0? That's the same thing, right? These two are the same. Are we cool? You guys understand what I'm saying here? So,
what they did
what they did was they gave you the graph of x squared minus 4, and they're saying, when is that smaller than 0? Well, it looks like it's smaller than 0. Let's do it in red. In this area right here, this range right here. Yeah? Yeah? What? What I mean by smaller than 0 is what we're talking about is, do you guys understand what the range is, right?
the range is the y values. So if I gave
Gave
you
you
an
an x value, there is a corresponding y value that is attached to this parabola. For example, for this x value, there's a y value that's way up here. Okay? So if I told you x equals 1, 2, 3, then you would tell me y equals 1, 2, 3, 4, about 4 for that graph. Right?
so what I'm
I'm
asking,
asking you is, when is the y values negative? When is the y values smaller than 0? That's all I'm asking you. And it's all of these areas right here. All of these x values will give you y values that are smaller than 0, that are negative numbers. We cool? So all you do is you just say, all right, well, it's these x values between here and here, and that looks like to me it's negative 2 and 2. So you're talking about x is between negative 2 and 2. Are we cool? Like that you understand?
so do you guys feel like you guys can turn in this homework?
Then
Good, good, because
you guys, some of you kind of bombed this homework and the next one. And don't worry if you bomb it. What I had a lot of people doing is, and I appreciate this, is they turned in the homework and they say, I have no idea how to do this, Mr. Belder. And at the very least, what that tells me is I better cover that in class, right? If I don't cover that in class, then a lot of people are going to get burned on this thing. So even if you're totally confused, turn in something to me, both of you. Because like that way I'll know whether or not you are either, look, you can even turn in a note to me that says, I understand this, I'm just too lazy to do this. And that way at least I know, right? At least I know that like this person is not dead. They they get it. So I don't have to like recover this stuff that is just gonna make their face melt off when I cover it because they're like, oh, this is so elementary. I don't understand why you're doing this. But like but they just don't have the time. They don't have the time to do it. Okay, I understand that. I'll hang with that. You'll still get a bad grade for that, but I'll let you redo that. Okay? And by the way, I don't know if you know, and I kind of been making up my own grading policy for this, but if you completely miss the assignment and don't turn it in at all, I give you a 2 points out of 10. I'll give you points for not turning in anything. 2 points. That's a 20%, which is still a low F. Right? The reason why I don't give you a 0 is just because I feel like if I give you zeros, that will devastate your grade so much that it would just like, it's hard to come back from that. So I'll give you 2 points. If you turn in something, and just turn in anything, like if you turn in a blank sheet of paper, I'll give you 4 points. Because I know that you've like tried, or at least you've even scanned something in. I mean, come on, give me something. But don't turn in blank sheets of paper. I mean, like I tell you, you can, and sure, I guess I would take it, but I mean, at least write a note and say, Mr. Dalday, your breath smells nice. Or, Mr. Dalday, I'm totally lost with this stuff. In fact, that would actually be more helpful to me. I don't really care what you think of my breath because it's online, but like if you just say, I'm totally lost, can you please explain to me what's going on in this problem? And you ask me specific questions. I mean, at least I know you've looked at it, right? And then pretty much if you turn in something, you can't really get below an F. Like, you can't get below a 5. And then I'll just kind of give you points accordingly to that. So that's kind of how I grade. Does that seem good or bad or nice or what? I don't know.
Very nice.
Alright, fine.
But
I need you to turn in your homework on time. You too? Alright. Anyway, can we move on to chapter 4? Do me a favor, do me a big favor. Can I do problems 1 and 3 on 16?
what do you mean 1 and 3?
3 on 16.
There is no 1 and 3 on 16. You mean 7 or 8? Is that what you want? Oh, 7 and 9?
Alright, let's do, alright, choose one. 7 or 9, which one? The difference is one is opening down and one is opening up. Alright, let's do 7. Fine, 7. That one does look harder, I agree. Where is this thing cross the x-axis? Good, that's the answer. Cross the minus 2. Yes, really, yes, seriously.
Same thing with number 9.
Same thing with number 9.
9, actually. It's negative 2 and positive 2. That's it. So, like you guys realize, wait a second, doing this homework wasn't so bad. Now, if I didn't give you the graph, then you guys would be like, Mr. Dalton, I hate you. Did you know that I hate you? Right? Because it would be harder. But I gave you the graph. I'll show you how to do it without the graph. Okay, ready? Negative x, or 2x squared plus 7 equals negative 8. I want to get x squared all by itself. Let me go through this real quickly. You ready? I'm going to put minus 7 over here and minus 7 over here. Okay? What is negative 8 minus 7? Mitchell, because I know you have trouble with negatives. Yes, negative 8 minus 7. Or negative 8 plus negative 7. Wait. It's not 8. That's a 1. I don't know why I wrote an 8. I have no idea. So it's negative 1 minus 7. Negative 8. Good. All right. So we have negative 2x squared equals negative 8. I think the reason why I wrote down negative 8 is that I was thinking negative 8 already in my head. All right. I'm going to get x squared all by itself. What do I do with that negative 2?
Yeah, what do I do?
Do with that negative 2 if I'm going to get it all by itself? Divide by negative 2 because it's being multiplied by the x squared. So I want to get rid of it. I want to divide it out. Negative 2, x squared. Adrian, you want to take this one? What is negative 8 divided by negative 2? Yes, I know that you know the answer. You can tell her if you want. You can ask her if you want. Oh, Roman is kind of giving you the excuse me. Yeah, very good, Roman. It's positive 4. Because it's negative 8 divided by another negative, which makes it positive, and then 8 divided by 2 is just 4. You good? Alright, now check this out. Ready? You square root both sides. You throw in that plus or minus, because you don't ever want to forget that. You have x is equal to plus or minus the square root of 4, which is, answer shoot, 2. Plus or minus 2. I have a question. Which one would you rather do? Would you rather read the answer from a graph or solve it out algebraically?
Read the answer from the graph.
Yeah, you can literally look at
The thing is saying, oh, it looks like plus or minus 2.
I mean,
Yes, I understand that, like, okay, so check this out. This solving it like how I solved it is actually pretty cool. And actually, you know what? We solved. That's what I was teaching. That's what I was teaching you on Wednesday. Was teaching how to solve it like that. So you learn how to do the second way, and the first way is I just kind of wanted to introduce you to this and say, hey, look, it crosses that. Now I've chosen these parabolas so that they end up landing in nice spots. There's a lot more parabolas out there that don't land in nice spots. And in that case, you're going to need different techniques. But for now, I've chosen parabolas that kind of land nicely on like -2 and +2. Oh, give me the plate.
You
I have
want
an
my
extra cord.
laptop? You want to use my laptop?
That's gonna be a lot easier because it can't reach that far.
What do you mean? It
Yeah,
seems.
but it would be like holding.
Alright, well, yeah. Pull that touch better anyway.
Mac. All right. All right. Can I move on then?
Quad 4, let's do it. Let's talk about what we're supposed to talk about today, and I've got an hour to do it. Are you guys ready? Alright. Can you do me a favor, folks? If I burn you for, like, not doing well on that stuff on chapter 2, can you redo that assignment? Please?
Would that be?
Make sure you redo that. And look, if you redo assignment, if you redo any assignment, I'm allowing you to redo it as many times as you want. To pretty much get any grade you want. If you redo it and you get like from a 6 to a 7, and you're like, wait a second, I don't want that grade. So you redo it again, you get from a 7 to a 9, and you're like, oh, and you end up getting an A in the end, that's fine by me. I highly encourage that. You know what I mean? So I want you to redo your assignments if you possibly do it. I think that would be good. But anytime you redo an assignment, I won't know whether or not to check the Dropbox if you change something in the Dropbox. Because I grade things and I just grade them, right? And if you change something back here, I won't know to go back and look. It doesn't tell me, it doesn't send me an email saying, hey, somebody redid something. Can you know? So what you're going to need to do is if you redo an assignment, make sure, A, that when you redo an assignment and you put in another thing in the Dropbox, say, oh, this is try number 2. You know, at least like indicate that in the title when you save it. This is like homework 1, try number 2, or you know, second part, or redo, or whatever. So I know to grade that one instead of regrading your original one, which would be kind of stupid. And also, if you redo an assignment, you need to send me an email to say, Mr. Galde, I redid this assignment. Can you go back and check that thing? And as soon as I get the email, I'll look at that and I'll be like, all right, fine. I'm going to go into the grade book and grade exactly what you sent me the email about. So that way I don't forget. Are we cool? So I need you to email me, because even if you redo it and you put it in the Dropbox and everything, I won't check it until you tell me to go check it. Got it? All right, listen to this one. Ready? I like this. Let's see it. Let's go back old school and let's solve for lines. Solve 2x minus 3 equals 0. Oh, really? You want me to do that? Alright, fine. 2x minus 3 equals 0. I want to solve for x. I don't need a square root. I just need to get x all by itself. How am I going to do that? You say divide both sides by 2, but I say before you do that, look. First thing I'm going to do is I'm going to look at the terms. Remember I talked to you guys about terms? Now there's one term that has an x inside of it. And there's one term that doesn't have an x inside of it. Since I'm trying to solve for x, I'm going to do math segregation. You've heard of segregation. I've talked to you about segregation before, right? It's the thing they did back in the 60s where they said black people are going to go to this school, white people are going to go to this school, black people cannot use water fountains that white people drink from. That is racist. We're doing math racism here. 2x, the x is in the 2x term. The 3 is not have an x in it. Let's kick him out. That's what we're going to do first. Which is not to say that I encourage racism at all. It appalls me. It really makes me sick. But I'm just letting you know, this is kind of the way I look at this. Like it's like I'm trying to get x all by itself, so I need to kick everything that's not x away. How do I get rid of that 3? That means saying bye by 3. Good, perfect. I have 3. Now I've got 2x equals positive 3. I'm going to get rid of the 2 now. How do I do that? Divide by 2. There we go. And I've got x equals 3 over 2. Cool? I'm just going through what they're telling me to do because I think that it's interesting. All right. Let's try another one. Y equals 3x minus 6. How would I find the x-intercept? Do you guys understand how to do that? How do you find the x-intercept? All right, fine. You need a graph. Let's do it. Here's a graph. Okay. And this is a y equals mx plus b kind of deal. What is the b in this case? Negative 6, so it's down 6. 4, 5, 6. And what is the m in this case? The slope? 3, so it's 3 over 1, really, right? So that means up 3, 1, 2, 3, across 1. Up 3, 1, 2, 3, across 1. So where does it cross the x-axis? 2, comma 0. Exactly. Now, I like the way Diamond is kind of going to suggesting we go about it. And so, like, I like the way you suggest we go about it because it's very visual, it's very graphical, but I hate graphing things in order to figure out an answer. Okay? Because one, my graph could be messy. I mean, you guys see how hard it is to graph a parabola. I think it's terrible, right? I mean, really, I've just been asking you, like, give me the basic shape. I don't actually ask you to plot those points out or whatever. Now, what Diamond is suggesting, and what you kind of came to the conclusion of, is that for the x-intercept, what do you know about it? Do you know that y equals 0? Wherever it crosses, y equals 0. That x could be anything, but y equals 0 guaranteed for bearings. Right? So in essence, if I told you, remember that f of x is the same as y? So if I have the graph y equals 3x minus 6, if I say y equals 0, then essentially I'm saying 0 equals 3x minus 6. You cool? And I want to solve for x. Well, you know how to do that. I'm going to add 6 to both sides, so I have 6 equals 3x. And x equals, how do I get rid of the 3? Divide both sides by 3, and I get 2. There we go. And that's how I would find the x-intercept. Okay? How do I find the y-intercept?
I'm not really gonna cross the line.
Make x equals 0. If you make x equals 0 in this equation right here, that becomes y equals 3 times 0, not 30, 0, minus 6. Minus 6. So it's 0, comma negative 6. Cool? So to find the x-intercept, you make y equal to 0. To find the y-intercept, you make x equal to 0. Are we cool? All right. Do you want a break? Do you want a break?
Yeah.
All right, I'll give you a break. 5 minutes? All right, 5-minute break.
Okay.
Double head scratch. Yeah, I know. I found myself having ukus lately. No, I'm just kidding.
Ew.
Just kidding. I'm messing with you. I just put like white chalk in my hair and it's hilarious.
Like rice.
Oh, that would be terrible. If I put rice in my hair,
And then, like, so I go up to you and she's like, oh, my hair is so itchy. And then, like, all the rice is falling all over you. You just hate me. Like, all this about it inside.
really, I don't feel like I changed anything. Oh, I like comic books.
Obviously. Because I'm a nerd. Nerds need comic books.
What comics do you like watching?
Oh, reading. Well, reading.
Really? I like.
I like Avengers. I like this comic book series called The Losers. It's a mature comic though. It's got a lot of blood in it. So I don't know if I could recommend it to my eighth graders or I mean you guys are ninth graders. I'm sorry. Ninth graders. I'm sorry. I had you guys as eighth graders.
Instead of having a batarang, he has a wingding, and that's just ridiculous.
A wingding?
Yeah, instead of having a batarang, Nightwing has a wingding. That's what it's called.
Sounds inappropriate.
Doesn't it? No, we are actually not. That is
You
new.
are not allowed
Yeah.
to leave campus.
No, they made a
If
big
you
deal out
if
of
you
it.
sign out, you're not allowed back on campus for the day.
By the way, we got.
We're on break. I'm just letting you know. We're not. This isn't class. This isn't how classes run. This isn't like normal class time. We're just on break.
This was never a rule last year. Needed. It wasn't demanded.
Well, here's the deal. Here's the deal. This is the reason why you can't leave campus. Is because if you're in a normal school, like if you're in a normal school, public school, whatever, could you leave campus to get lunch?
Yeah. Moana Lua does that.
Really?
Yeah.
I believe if you're not all grades, what grades
Well, that's only me. Because you know what?
We did that last year.
The reason being is because what happens is if you leave campus, see, once you set foot on campus, we are reliable for you. We claim responsibility for you.
Catholic school is different.
Because it's not a public school.
Catholic school is different because
You
it's
just
not
want to be
public school.
free.
You just want to be free. Yeah.
I understand that.
I hear your plight, but I'm just saying, this is kind of what the deal is. You know what? You just want to be free. I'm going to represent the school side and say, I just want to be stingy with my money.
We just want to be teenagers.
And I don't want to pay your parents. I don't want to pay your parents if they sue me because you go off campus and you get hit by a bus. Because technically, you would be my responsibility. If you go over to if I have my kids, right, my kids, and my auntie, their auntie, my sister picks them up, right, and she goes, I'm going to go take them out to dinner. I was like, that's cool, you know what I mean? And then she like comes back and she's like, I lost one, just letting you know. But don't worry, we have two left, right? I'd be like, you were responsible for them. I gave them to you in my I was trusting you to take care of them. You can't just lose one. How is that different? All right, fine. Let's do this. What happens if like
What if our parents sue
Your
you because
parents-
you didn't let us eat?
Yeah.
Well,
We die of
I'm not
malnutrition.
letting
you not eat? I'm just not letting you
Then can you
get
share your
food.
can you share your food with
Ha
us?
ha! Yes.
Okay, fine. Couple notes of this.
All right. So today's out. Ready? Let's start class. Are you guys ready? You guys back? Mentally? All right. All right. If you're ready, say tomato. That way I know that you're listening. No, not tomato. Say tomato. Come on. Potato. All right. But Amanda seems to be like the only one in this class, right? Amanda and Diamond. They're like, I'm going to answer all the time. Blah, blah, blah. There we go. There we go. By the way, in Carter with the Chance with the Meatballs too, what was the deal with like, oh, it's just a tomato? I don't understand that. No, but
The first one was good.
the second one was
Look
so
at
good.
this cute.
All right. Anyway, let's go. So check this out. Here's what I'm going to do. I'm going to pretend like, all right.
We're talking about multiplying things together, and we were talking
About foiling, right? We did this thing where we had like x minus 3 times x plus 1, and you guys learn how to foil that, right? When I'm talking about multiplication, I've got like A times B.
If one of those is 0, what do I know about this thing?
It's gonna be 0.
What's going to be 0?
Oh, 1.
There we go. There we go. I love it. I love it. Let's write that down. Something.
You know what?
0.
I'm going to type it up.
0.
Enter. You like that? That was fast enough for you? Huh? I'll do it again, right? I'm going to do Enter. There we go. Mitchell was talking to me about how slow I type. Really? I can't believe how slow I thought I typed fast. All right, fine. You know what? I just don't type with your thumbs. You kids nowadays, whatever, crazy stuff. All right. Something times 0 is always 0. Right? Something times 0 is always 0. If I, no matter what it is, it could be 5 million, but if I multiply it by 0, the answer is going to be 0. Right? We good? You sure?
Yes.
Good. That's the concept. That's all. That's the concept I want you to know.
Yes.
But let me show you how that applies to this.
If I have something like this, if I have x times x minus 2 equals 0. Got it?
And I'm going to look at this as like two parts. If x equals 0, so I'm saying if
X equals 0.
then I plug in x 0 for x over here, and I have
0 times 0 minus 2.
what is 0 minus 2? Negative 2. But does it really matter?
No, because I'm multiplying it by 0.
And if I'm multiplying it by 0, the whole thing's just going to be equal to 0 anyway. Right? Or I guess the question I'm asking is, what values of x make this equation true? And one of the values of x could be x equals 0. Does that make sense? What other values of x make this equation true? There's another value. I can plug in x equals something else, and it would make this equation true. You guys see what I'm getting at here? No.
Sure.
All right. Here, watch. Check this out, right? I have...
All right, let's kind of look at this closely. I can either say this equals 0 right here, or I could say this equals 0.
Because if the second one equals 0, it doesn't matter what the first one is, because if I multiply them together, it's going to equal 0 in the end. Does that make sense? So
I could plug in x equals 2.
how's that? Because check this out. If I plug in
X equals 2 into here, I would have 2 times 2 minus 2 equals 0.
what's 2 minus 2?
0.
0.
Times 2.
It doesn't matter what the first one is, because if I'm multiplying by 0, it will still equal 0 in the end. Does that make sense? No? Yes?
Yeah.
Okay. All right, fine. Let's try this one. Let's do this one together. Okay? Write this down. Write this down.
X minus 3 times x plus 1 equals 0.
Now, I'm not going to ask you to FOIL this out. What I'm asking you to do is solve for x. Tell me what x is equal to. I need 2 pieces of paper. Do you have any paper?
Is this the same thing with like the husband and the wife?
It's kind of like this husband and the wife. Hi, nice to meet you. It's kind of like, here, give me a piece of paper.
You would have to.
Is this good? Are you sure? All right. You're welcome. All right. Here, look. Here's what I mean. Okay.
X minus 3, x plus 1 equals 0.
All right. You ready? Adriana, move in. Mitchell, come in so you can be in the shot.
I am not used.
What are we doing?
Oh, it's never
Oh, we're-
used as an example.
All right. I think you gotta turn it over a little bit. Can you guys see this? This is what I have. I have x minus 3 times x plus 1 equals 0. Mitchell, you're 0.
Isn't it backwards?
Not a
It should
hero.
be the opposite.
You're 0.
Because you read left to right, so it's equals 0.
Wait,
It's
let me-
something like that.
That's not written correctly? Oh, fine, here. I'm 0. Fine, I'm 0.
What?
Because they have to.
Wait, what?
They read
Here.
it from left.
Okay, is that good? Does it make sense now? Alright, there we go. Alright, so we got x. Move in a little bit.
I
Move in.
cannot.
Alright, here, I'll move down there. We got x minus 3, we got x plus 1, we got that equal to 0. Okay? Now, how can I make it so that this times this equals 0? Can I make it so that Mitchell times Adriana equals 0? Either Mitchell can be 0, right? And if Mitchell is 0, if you're indeed 0, does it matter what Adriana is?
Mm-hmm.
No, she could be a billion. If you're 0, you times you is still going to equal to 0. Does that make sense? All right. Now, or there could be another possibility. What's the other possibility? Either Mitchell is 0 or Adriana is 0. Because if Adriana is 0, I don't care what Mitchell is.
Thanks, Mr. Duck.
Yeah, I don't really care. Whatever he is, times 0 is still going to equal 0. So I have two possibilities that I can check. Right? What I was saying is, thank you. What I was saying is either x minus 3 equals 0 or x plus 1 equals 0. Does that make sense to you? Either the first thing is equal to 0 or the second thing is equal to 0, because if either of those are equal to 0, then, those two multiplied together will give you an answer of 0. We cool? So, how do I figure out what x is? Well, all I got to do is add 3 to both sides, so I have x equals 3. Or x equals negative 1. Are we cool? Does that make sense to you? By the way I got negative 1 is I subtracted 1 from both sides, and I get x equals negative 1. Yes? Good? Good? Kind of? Makes sense? You want me to do another one? I'll do another one without having the dummies. I just called you dummies.
What? I totally was spaced out.
Alright, let's do this one together. Ready? I'm going to do it in a different color. Write this down. When you take notes, by the way, write things down. X plus 2 times x minus 4 equals 0.
There are two things I can say if this is going to be true. Either this first thing is equal to 0, or the second thing is equal to 0. So
Either x plus 2 equals 0, or x minus 4 equals 0.
are we cool? And then solve it out.
You just subtract 2 from both sides and you get x equals negative 2, or x equals positive 4.
That's how you solve these quadratics. What we call this factored form. Because usually what you've been seeing the quadratics is as like 3x squared plus 4x plus 2 or something like that. Have you been seeing it like that? Or in quadratic, in the first problem, we asked you to FOIL these out, and you would get something that looks like that. When it's in this form, it's actually easier to solve, so we don't want you to FOIL it out. In fact, later on, we're going to teach you how to turn it from this, the x squared plus 3x plus 4 or something into the factored form. Later on. I think that's coming up in, the next chapter. All right, so the answer for this problem right here would be x is equal to negative 2 or positive 4. We good?
All right. This right here, page number 2, problem number 1, is your homework. In fact, all of this is your homework, and I'm not going to do your homework for you. But I'm going to do a problem that is very similar to your homework. I'm just going to change the numbers a little bit, and then, then you can do your homework. So the way we would normally do this is, let's make a table. And we'll go -2, -1, 0, 1, 2, 3, 4, 5. All right. All I want to do is I want to replace x with these numbers that I made a table for. So let's try it out. If I plug in -2 into here, and by the way, keep in mind that what I'm doing here on this graph on page 2 or whatever is not your homework. It's a separate problem that I just made up. I made this up. What are you talking about, Diamond? Me what?
Since you got it.
Oh. What is Raimana asking?
Raimana's just saying nice beanie. Yeah.
Why? Yeah, I do. Mine was like $20.
I like free better.
No, but mine is.
Yeah. Anyway, they're having beanie wars over here. Hey, stop fighting. Or makes me think that makes me think that you guys are in love, and then you guys are gonna have beanie babies. Ah, that was a good one, huh? That was a good one. All right. Anyway. All right. So let's plug in -2 in for x over here. We plug in -2 in for x. What do I get? I've got -2 minus 2, which is -2 minus 2, which is
-4.
-4. So I've got -4 times -2 plus 1, which is -1. Right? What's -4 times -1? +4. So if I were to graph this, I would graph it at -2, +4. Like that. Cool? Alright. What if I plug in -1 into here? What's -1 minus 2? -3. What is -1 plus 1? 0. What is -3 times 0?
0.
0. There we go.
And now I'm going to plug in 0 into here. So I've got -2
times 1. That's -2. Good? Like that. And then, let's see. Let's plug in +1. I've got, what's 1 minus 2? -1. What is 1 plus 1?
2.
2. So that's -2 as well. Let's plug in 2 into here. What is 2 minus 2? All right. 0.
I'm thinking about it.
And what is 2 plus 1?
3.
It doesn't matter, because 0 times 3 is still 0. What is, let's plug in 3. 3 minus 2 is what? 1. So 1, and then 3 plus 1 is 4, so that would be 4. Can you draw a parabola at this point?
Yeah.
Looks something like this. By the way,
this is not this problem right here. This is a problem I made up. For your homework, you're going to have to do this problem right here. You guys get it? But for your example, I'm doing a problem that is oh so similar to this problem. Are we cool?
that would be the slow way of graphing it. No, I like the slow way. The slow way is good. Plug in numbers. We good? By the way, if I were to graph, like, what was it that I graphed?
This is x minus 2 times x plus 1.
What are the intercepts? If I set that equal to 0, that would be how I would find the x-intercept, right? That would say that you can either say x minus 2 equals 0, which tells me x equals what? If I said right, if I'm looking at this and I'm asking you where does it cross the x-axis, you can either say x minus 2 equals 0, which tells me x equals... Come on, folks. Online.
X equals what? Where's your shoe?
2. Because you add 2 to both sides. Or you could say x plus 1 equals 0. And what is x equal to then? In that case. What is it?
Negative 1.
-1. And look, where does this
Parabola cross this x-axis at 2 and -1.
Are we cool? How would you find... Oh, yeah, this is a good problem right here. Let's ask you this question then. Now, where's the vertex? It's right over
Here. Right there. Vertex. Vertex.
We cool?
How can you use... I'm just curious to know if you kind of can get this. I'm thinking maybe I should do a different problem. Alright, let's move on to a different problem.
We should do the homework.
What is that?
We should do that one.
Alright, fine. I'll do your homework problem for you.
Let's do this one together. This one's actually straight from your homework, and I'm doing this off of Adriana's suggestion. So everyone say, thank you, Adriana. No, I'm waiting for it. Come on, thank you, Adriana. There we go. Diamond and Romana are the only ones that are talking in class. There we go. Give me a line easy enough. Alright. Let's plug in -3 into here. If I plug in -3 into here, I'll have -3 plus 1, which is -2, and -3 minus 3, which is negative what? -6. So -2 times -6, which is positive 12.
Does that make sense? So, at
-3, I got to go up to positive 12. That's the point right there.
cool?
Alright. Plug in -2 into here. I've got -2 plus 1, which is -1. -2 minus 3, which is negative what? 5. -1 times -5 is positive 5. There we go. So we graph at -2, positive 5, somewhere around here.
Cool? Alright.
I'll tell you what, instead of me going through this, why don't you plug in -1 into the thing and tell me what your answer is. It's x plus 1 times x minus 3. Kimilani, or Kaimilani. Is it Kaimilani or is it Kimilani? Is it Kaim? How do you pronounce your name?
Yeah, it's going to be hard to say.
You can turn on your audio if you want and tell me. I feel bad. I don't want to actually say Kimilani or Kaimilani.
Alright, I'm going to say, is it Kimilani? Yes or no?
Maybe she went to the bathroom.
Maybe. Yes, Kimilani. Alright, good. Kimilani. I got it right the first time.
So Kimilani is correct. It's 0. Did you guys get 0?
Yeah.
Awesome.
Plug in 0. I love plugging in 0 for x. That's 1 times -3.
-3. So that's that. Plug in 0, I get -3. Alright. Plug in 1, what do you get?
What do you get? You're plugging 1.
What? I'm still doing it. I just started.
Okay. Plug in +1 into there.
Everyone's just silent. All right. If I plug in positive 1 in here, I get 2 times negative 2, which is negative 4. Awesome. All right, plug in 2 into there. So I've got 3 times negative 1, which is negative 3. Okay. Filling out the rest of this graph is going to be easy, by the way. I'm just letting you know. If I plug in 3, what do I get? 0. I'm gonna tell you what. I'm gonna plug it in real quick. Ready? 5 and 12. How did I do that so quickly?
Because parabolas kind of have this nice symmetry to it.
And once I found the vertex, which is over here at negative 4, I know that the numbers on top, look, it's 12, 5, 0, negative 3, negative 4, negative 3, 0, 5, 12.
It kind of like does exactly.
Opposite.
Yeah, I don't. However you want to say it. We cool?
So if I were to graph that, I mean, that makes it probably that's nice, easy to graph. Like that.
Where are the zeros? Where does this thing cross the x-axis? At
Negative 1 and positive 3. Which is good, because look, remember what we've been doing? If I said x plus 1 times x minus 3 is equal to 0,
I'm saying, when is that equal to 0? You could say either x plus 1 equals 0, which tells me x equals negative 1, or x minus 3 equals 0, which tells me x equals positive 3. Guess what? I solved it, and it corresponds to exactly what we thought it would. What the graph is telling it would. We cool? Now here's the thing. What are the coordinates of the vertex? Where's the vertex located on this thing?
at 1, negative 4.
All right. Pay attention to this, because this is very subtle right here. I could have told you, if you told me that the intercepts right here is negative 1 and 3, I could have told you that the vertex is at x equals positive 1. I could have told you that. Without making a table, without graphing it, I could have told you that the vertex is at x equals positive 1. How would I have been able to figure that out?
Because the range of the 2 points on the x-axis.
What do you mean the range of the 2 points? Range is the y value, so it wouldn't be the range. But I mean, I think I see where you're going with this. Remember, I hate pulling equations out of my butt, so I want to discuss this with you. Plus, Adriana is so close to me that she was like, I don't want to hear anything that has to do with your butt. It's disgusting. So I don't want to pull the equation out of my butt and just say, this is the rule. I want you guys to kind of figure it out. Look at this. How did I know that
if I know this point right here, and this point right here, how did I know the vertex is going to come right over here?
Just because,
I love it, Diamond. That's exactly it. Diamond says, because it's in the middle. Exactly. I mean, if you think about it, right? Yes, exactly, Thomas. It's at the center of the two intercepts. It's right in between. I guess you could say it's the average. How do you average something? If I gave you two numbers, how do I average it? This doesn't say anything to me. How do I average something? If I gave you the numbers like 2 and 8, what's the average?
middle.
No, it's you add and then divide by the number of digits. Exactly. You add them together. Remember how to average something? You add 2 plus 8, and that gives you 10. Divide that by however many numbers you do. You add it together, so it's 5. We're good, right? You guys understand how to do that? You guys remember how to average something? So in essence, you could average negative 1 and 3. If I add negative 1 plus 3, it would give me what? Negative 1 plus 3,
Two.
you give me 2, and then divide that by 2 because I add two numbers, and you get 1. X equals 1. That would be a good way to figure out the vertex. I'm just suggesting that, like, on Sunday, hopefully you guys are going to watch football because football is cool. It's an all-American thing. If you don't watch it, then maybe you're from Europe and you like soccer. But well, I'm going to go to my parents' house because I don't have cable either. But yes, is the
Seahawks and the Broncos, right?
yeah Seahawks and the Broncos. And we got football. But here's what I'm suggesting to you. Would you guys agree with this? What I'm suggesting to you is the quarterback is going to throw the ball, and the receiver is going to catch the ball. Now, at some place between when they throw the ball and when they catch the ball, it's going to reach its highest point, right? Where would you say the highest point would
Middle.
be? Exactly in the middle of where he threw it and where he catch it.
So no, I'm totally breaking away from math right now.
Seahawks or Broncos. I was at Berkeley when Pete Carroll was at USC, and Berkeley lost to USC that year by only like a point, and I was so devastated because they had Reggie Bush on their team, and then turns out that Pete Carroll was just like this big fat cheater because he shouldn't have had Reggie Bush because he cheated, and so they like washed that season away. But then like I have this deep
That's
hatred
question.
for Pete Carroll, which is the coach for the Seahawks. So down with the Seahawks.
Seahawks are
I want to see Peyton Manning
Doesn't matter.
kick
It's
their butts.
already-
Seahawks are gonna
Just letting you know.
Sorry, estimated outside to make it a close win for the Broncos or a blowout for the Broncos.
Oh, you mean the Broncos are going to either win by a little bit or win by a lot?
They estimate that's going to happen.
Close game or blowout.
I don't know. I think that the weather actually is going to play a huge difference in the. I mean, look,
Yeah.
the weather is going to be like
So used to
highs 49 degrees. What the heck is that? High 49? That's what? Lows 29 degrees. Wind chill factor, another negative 10 or whatever. There's a 10% chance of it raining. And if it rains at anywhere below 32 degrees Fahrenheit, which is actually freezing water temperature, then the water is going to freeze on the way down and you're going to have a hail or snow. Either one not good for a quarterback. I'm just saying. But
used to
I hate Pete Carroll. And I'm not going to go into this because this is not what math is. Let's go on.
Talking about parabolas and football.
No, but yeah, what I'm suggesting in football is that if I throw a football and I'm the quarterback and someone out there is a receiver, it will reach its highest point when? Wherever is exactly the middle of where I am and where he is. Or her. Doesn't matter. Does that make sense? Well, could you guys agree with that? Would you guys be like, I could hang with that? So maybe a good way to find the vertex without making a table is this. If we know that the vertex is going to occur at x equals positive 1, then we can take that positive 1 and plug it into our equation and figure out what the y value is. Right? Because we have the x, we want to figure out what the y value is. So we plug positive 1 into here, and we have 2 times 3, or 1 minus 3, which is negative 2, which is negative 4. And so, boom, I got the vertex without looking at the table. Does that sound like a very viable way? So, I mean, I could give you this graph. X plus 1, x minus 3. And then I could say, check this out. I can tell you, just by looking at that, where the thing crosses zeros, where it crosses the x-axis, and where the vertex is. Just by looking at it. No, don't make a table, don't make a graph. I'm going to look at that and say, it must cross at negative 1, it must cross at positive 3, the vertex must occur at positive 1, and so the coordinates of the vertex is positive 1, negative 4. Done. Boom. Deal with that, suckers.
Oh my mind.
I know, isn't that kind of cool? Like, wouldn't you be bad to the bone if you could walk into a room and just do that? And you'd be like, Randy, how do you do this problem? And you'd be like, well, the answer is negative 1, positive 3, and the vertex occurs at 1, negative 4. And just walk away. You know what I mean? Just drop your pencil and walk away. That's what you should do.
Pencil.
What if you need that pencil later?
No, then you buy a new one. You don't go back and pick it up. I mean, that just
No.
like ruins your coolness.
Miss Dota, you did that like 3 times already.
Yes, that's true.
Like
All right.
exit the room, but then you forget your bag.
I know. Booyah! Mind blown! And then you like forgot
Slams
your
the door.
phone on the table. Just like, yeah, I'm an idiot. Sorry. All right. Anyway, let's see. Reflection. What is the connection between the x-intercepts for the quadratic function and the location of its vertex?
Didn't we just do that?
Yes, I know. I'm just reading the question as is. What is your answer? By the way, this is also from your homework.
In the middle.
It's in the middle.
Two.
I like it. If you know the x-intercepts of the quadratic function, how do you find the 2 coordinates of its vertex? If I know the intercepts... Okay.
What are you reading?
I'm reading the second part. This is from page 4. I'm actually still doing your homework for you.
You need to write on the wrong one.
So maybe you... we're on page 4, everybody. If I know... Okay, I like what Diamond says. I'm going to find the average.
But Diamond, what will the average tell me?
Where the what? Where the vertex is, it will only tell me one part of the vertex. It will tell me what the x value of the vertex is. How do I figure out the y value? Well, once I know the x value, I can just plug that into my function and then figure out what the y is. You just take it and plug it in. So that's how you would get the 2 coordinates. To get the x value, you first have to find where it crosses. And then you take the average of that. You find the middle. And then to get the y value, you can't get the y value without first getting the x value. And then you just simply take that x value, plug it into the original function. Boom, you're done. Does that make sense? I don't know why I always do that. Does that make sense to you? I have a very itchy head, I suppose. I should probably shampoo more. Conditioner.
Move over a little bit.
Yeah, I know. My head's been really itchy lately.
You
All
have
right.
short hair. You went like your hair.
Mine's so soft.
Oh, yeah?
That's why
Oh,
you
yeah.
have bees.
I would ask you if I could feel your hair, but that would be inappropriate. Let's move on. Let's try this one. In fact, what I'm going to ask you to do is graph this, and I'm going to even do this. I'm going to play this game with you guys. Let's graph this, not make a table. Let's just graph this. Look at, I'm on page number 5, I think. Problem number 1. This is not your homework. Your homework is problem 2, but I'm going to do problem 1. All right, let's try it. Where are the x-intercepts?
What if I just copy what other people say?
Well, no one's not really saying much, so I mean, I need you guys to...
What page are we on?
All right. Thomas is saying you could...
FOIL this out, and this becomes x squared minus 6x plus 8.
And Thomas, I would agree with you, but I would say that's a terrible idea. Technically, you're right, but it's not necessarily what you want to do. You don't want to FOIL this out. In order to find the x-intercepts,
You would set this thing equal to 0.
right? Now, if I set that equal to 0, we covered how to solve this thing. How to figure out what x is equal to.
Exactly, Diamond. Diamond is suggesting that x equals positive 2 and x equals positive 4.
How did she figure that out?
Because she's smart.
Yeah, because she answered everything.
Actually, Diamond hasn't been turning in all of her homework. I'm not saying...
Don't
I mean,
call her out.
oh, you're right. Okay, fine. No, but I'm just saying that, like, Diamond is a smart student, but, I mean, like, she needs help, too. So don't, like, feel like, oh, she's just Diamond, or she's smart. I mean, I can't ever touch that. Right?
I actually, I get that.
But, I mean, Diamond, you know that I have mad props for you. You know that, like, I think that you're super awesome. Because, I mean, we have a history, too, together. But anyway, do you guys understand how she got positive 2 and positive 4?
It's the opposite.
Well, I mean, all she did was set x minus 2 equals 0, and or x,
Minus 4 equals 0.
and this tells you x equals 2 and x equals 4.
Plug in 0 to x.
Plug in 0 for x. Why would you do that?
No, it's a
X equals 2 and x equals 4.
right, exactly. And you know what? I actually kind of like what Mitchell said. Mitchell kind of made an observation. He said, "Hey, it's just kind of the opposite of what this is." Okay, all right, cool. Yeah, you're right.
But is it always the opposite?
Is it always the opposite? I don't know. You can figure that out. But I'm just letting you know.
All right. So we know that the thing crosses at 2 and 4.
Remember, I'm not making a table. I'm just looking at this thing. Where's the vertex? If the crossing points is going to be at 2 and 4, I could have a
Parabola that looks like this, or I could have a parabola that looks like this.
I'm not sure.
It'll cross at 2 and 10.
So where's the vertex of this thing? Diamond's saying 3. How'd you get that? Because 3 is in between 2 and 4. That makes sense. Vertex. But that's not the actual
Where the vertex is, that's only the x for the vertex is at 3.
We cool? What's the y? How do we figure out what the y value of the vertex is?
I plug in 3 for x in my original function. So I have,
What is that? 3 minus 2,
which is 1, times 3 minus 4, which is negative 1, and my answer is negative 1. So apparently my vertex is right here. Those 3 points alone tell me what this parabola looks like. It looks to me like it looks like a regular parabola
shifted over to the right 3 units and moved down 1.
Except you put it on a negative 2.
What do you mean?
vertex. Oh, you're right. I did. See, that was me being cool and not barely being cool. It's negative 1, so it kind of goes like that.
So it should probably look something like that. We cool? No table.
You want me to indicate what the x-intercepts are? Fine. 2, 4, and 3 comma negative 1. That's the vertex.
Good? Oh, you want me to tell you what the y-intercept is as well. That's pretty easy to do. You guys want to know how to do that? Because it asks me, it tells me,
What are the x-intercepts? What's the y-intercept and what's the vertex?
all right, fine. The y-intercept is pretty straightforward. How do I figure out the y-intercept of something? We started class off with this. I want to figure out where it crosses the y-axis. What do I know about it?
Here.
I'll bring you
Back to the first page that we did. If I want to figure out where the x-intercept is, I know that what? Y equals 0. If I want to figure out the x-intercept, y equals 0. If I want to figure out the y-intercept, then x equals 0. So what I was asking you for here is what is the y-intercept? All you got to do is plug in x equals 0. So you plug in x equals 0 and we get negative 2 times negative 4, which is 8. And look, it kind of crosses right over there where we thought it would. That's our problem.
Are we cool?
You guys can do this, and you're like, boom, I got these parabolas. We good? You're not going to freak out when you like go home and just be like, I can't understand anything. We did. All right. Good. I know that
The class is going long. I apologize.
Nine, 10.
When you have to graph this, by the way,
let's just do the warm up for this next part, and then I'll end class. Okay. The warm up. Graph this for me. How do I graph that?
2x squared minus 1. This is page 7.
No, it doesn't have no parentheses around anywhere. 2x squared minus 1 graphic. What do I do? Hint. This is a warm-up. So it's asking you to remember things.
You're good at remembering things.
Since I taught it to you on Wednesday. 2x squared minus 1. You know, 2x squared minus 1. Y equals 2x squared minus 1. I'm not even going to like make a table or anything. Ted's saying PEMDAS. I'm saying no. Fine. Give me this. Do me this favor. Graph y equals x squared. What does that look like?
Draw that graph. You got that graph? Tell me when you're done. Alright. Graph this. X squared minus 1. Try graphing that. What do?
Down.
You take your parabola.
And you down it. Now graph 2x squared minus 1.
Oh, we just did this.
I told you we just. That's what I told you. You make it.
Go down one.
You make it thinner or stretch it. You take the gummy bear. You like a gummy bear. You go like, oh, don't tear me apart. Ah, and you'd be like, where are the secret documents? I'll never tell you. And it's never. Yeah, exactly. So the graph would look something like this.
Probably something like this. Cool? Alright.
That's it. I'm done with class. You guys like it? Does this make sense to you? Does any other question? I've got 5 minutes left. Yeah, I'm gonna V for Vendetta, you guys, and just be like, all right, gummy bears. I should really, when I teach this lesson next time, I'm totally gonna get a gummy bear. I'm gonna be like,
gummy bears.
yeah, I'll just get gummy bears and just be like,
And then we can eat them.
don't. Where are the secret files? I'll never tell you. Well, then you die. Yeah, and then you guys are like, Mr. Dogdays, cray cray. Like, I said cray cray. All right, anyway, I'm done. Yeah, I want to get a giant gummy bear. Either that or I'm going to take the gummy bear and hold it up to the screen. There's what? 50-pound gummy bear?
I have a gummy bear lamp like that. It is a
See, if I had a 5-pound gummy bear, I wouldn't want to buy one every year. So I'd kind of want to reuse it, which is kind of disgusting.
I just constantly
But gummy bears in packages probably last longer than 5 years, right?
yeah.
Just don't open
Let's
it.
not try that.
But I mean, no, I could get a 5-pound gummy bear in the package, and then I'll just like grab the package and be like, "Don't kill me," or I'll be like, "You die by smash, smash your head." All right. Anyway, I gotta go.
I have class. I have a class at 11 o'clock.
See ya. What are you guys doing?
So when you biology, each of them, where do you live?